Hello again, this is Mr. Motugi in our today's lesson for mechanics of machine. Previously, in our previous lesson, we looked at the symmetric cross-sections and specifically the I section of a beam. We were able to calculate the moments of inertia, and in our today's section, we are going to look at the moments of inertia of asymmetric cross-sections. Basically, asymmetric cross-sections don't have a definite neutral axis. A T section of a beam is a good example of an asymmetrical section of a beam. The beam basically consists of two parts, that is the top flange and the web. It doesn't have the bottom flange that is opposed to the I section of a beam. We are going to go direct to the calculations. The first step in the calculation of moments of inertia of a T section of a beam is to find the neutral axis of the section. That is, the neutral axis is an axis that is actually horizontal and that passes through the center of gravity of the section. For example, in this case, we are going to see how we are going to calculate that. Basically, to calculate the moments, the center of gravity of the section, we are going to consider the bottom axis or the bottom of the beam. That is, we are going to determine the center of gravity of the section with respect to the bottom axis. It will be given by A1y1 plus A2y2 over the summation of the areas. That is where y1 is the distance of the center of gravity of the section. That is 1 and 2 from the bottom axis. For example, in section 1, we are going to see that the area is actually A1 is equals to 100 times 20. As you can see, the base of the section is actually 100 and the thickness is actually 20. And the distance of the section from the bottom axis is actually 80, as you can see here, 80 up to there, and then plus half the distance, because the center of gravity of section 1 is half distance from the bottom or from the top of the section. That is actually 10. So it's actually 100 times 20. That is the area, and the y1 will be, that is 90. And the y2, the same case. That is actually 80 times 20. 20. That is the area. You multiply by the distance from the bottom axis. That is actually 80 over 2. As you can see, the center of gravity of the section 2 will be somewhere in between. That is at the center of the distance, 80 millimeters, giving us the answer that we have here. That is 67.77 millimeters. That is, we mean that the center of gravity of the section will be actually, considering the bottom axis, it will be at a distance 67.77 millimeters from the bottom axis, somewhere here, as we have drawn it here. This is actually the neutral axis. And considering the entire height of the section, it's actually 100. The height of the section is actually 100. So 100, you subtract 67.77, we can see that the neutral axis is at a distance 32.33 millimeters from the top of the section. Going to the second step, that is now calculating the moments of inertia of the section. We are going to see that the moments of inertia of the section will be given by the summation of the moments of inertia of section 1 and the moments of inertia of section